Hello everyone. We're going to be doing two sections today, so if it's a little bit longer of a video, that is why, because we're doing two different sections in the textbook today. Kind of related to each other, all about rhombuses, squares, and rectangles. Okay, so there are certain types of parallelograms that have special properties. These are the three main types we're going to be talking about today. A rhombus is a parallelogram with four congruent sides. All the sides are going to be congruent. That's the rhombus. The angles are not. A rectangle is a parallelogram with four right angles. Here, here, all these are right angles. Notice how it doesn't say anything about the sides being congruent, because parallelograms automatically have opposite sides being congruent, so we don't have to say that again. A square is a parallelogram with four congruent sides and four right angles. So you guys all know what a square is. So this is kind of like a combination. Square is basically a combination of a rhombus and a rectangle. This Venn diagram can show this relationship between rhombuses, squares, and rectangles. So we have some things that are only rectangles, some things that are only rhombuses, but when they two are combined, those will be squares. Okay, hopefully you guys have no problem with these things. These things should be known already. We're going to go through three theorems in this one section, and two problems, and then the next section has something similar. So next I'm going to state some theorems, we're going to prove it, and then we'll go on to questions. Okay, so this is the first theorem from this section. It says that if we have a parallelogram and that parallelogram is a rhombus, then the diagonals of that parallelogram or that rhombus are going to be perpendicular. So basically what this says is, here's a rhombus, I draw I draw diagonals. Those diagonals are going to be perpendicular lines. We're going to make right angles at all of these different points. So rhombuses are going to have diagonals that are perpendicular to each other. Theorem 614, if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So here's a rhombus, A, B, C, D, and I didn't have enough room to draw all of these different angles in here. So angle 1 would be here, and angle 2 would be here, and they would be congruent. Angle 3 would be here, and angle 4 would be there, and they would be congruent. Angle 5 and 6 would be here, and they would be congruent, and 7 and 8 would be here, and they would be congruent. 7 would be on this side, 8 would be on this side, etc. for all the others. So just know that when you have a rhombus, the diagonals are going to be perpendicular, and they're also going to bisect the opposite angles. We have a proof, and we're going to prove theorem 613. So this one is, we're given that this one is a rhombus, and we're asked to prove that these diagonals are making right angles. So giving off our statement and reason, A and C are going to be equidistant from B and D. So A is equidistant from B and D, and and A is equidistant from B, and C is equidistant from D. D is equidistant from A, and B is equidistant from C. So all these different things are going to be equidistant. That's because all sides of a rhombus are congruent. I forgot to make a congruent symbol here. So just imagine this congruent symbol right here. So these are all equidistant because rhombuses sides are all congruent. Then, I might as well just show it all. A and C are on the perpendicular bisector of BD. B and D are on the perpendicular bisector of AC. And that's the converse of the perpendicular bisector theorem. Hopefully you guys remember that theorem. Last one, AC is perpendicular to BD, because through 2 points there's only one unique line perpendicular to a given line. So if we have questions about this proof, you guys can say it at the end of the video, and we'll go through it in class. Now we're going to go through some questions with rhombuses and their angles. Okay, so here we're giving a question with a picture. And I'm going to go through each one. Alright, so what are the measures of angles 1, 2, 3, and 4? Well, angle 1 is going to be easy. It's going to be 90 degrees because rhombuses at diagonal make perpendicular lines. And then we're told that this angle is 58. If this angle is 58, that means angle 2 is also going to be equal to 58. That is because of alternate interior angles. We have two parallel lines, pretend they're like right here, and a line cutting through. The alternate interior angles are going to be congruent. So this is 58, angle 2 is 58. Angle 3 is also going to be 58 because of a diagonal of a rhombus makes the opposite angles into congruent angles. So it bisects the opposite angles. So 2 and 3 are going to be the same. Now we just need to find what angle 4 is. But we have this smaller triangle here. So we can do 1 plus angle 3 plus angle 4 equals 180. And we substitute in 90 plus 58 equals plus angle 4 equals 180. 148 plus angle 4 equals 180. So angle 4 is going to be 32 degrees. Now you're going to have a problem on your own. So you're asked to find the angle measures of 1, 2, 3, and 4 for this rhombus here. Alright, now we're going to go on to the last theorem we have, and that has to do with a rectangle and its diagonals. So if we have parallelogram as a rectangle, then its diagonals are going to be congruent to each other. So if I have some rectangle here, A, B, C, D is a rectangle because I have the right angles, then I draw diagonals to each other. These diagonals are going to be equal length. AC is going to be the same length as BD. Now we're going to go through some problems with this, and then we're going to move on to the next section. Okay, so this one says in rectangle RSBF, SF is equal to 2x plus 15, and RB equals 5x minus 12. What is the length of the diagonal? So here we're going to have to set these equal to each other, find x, and then move it back into one of these equations. So SF is going to be equal to RB. So 2x plus 15 is equal to 5x minus 12. I'm going to move the 2x over here and move the 12 over here to get 27 is equals to 3x, and then x simplifies to 9. Then I could choose any equation I want. I chose SF. You could choose RB. That's up to you. And plug it back in. So 2 times 9 plus 15. Remember, I'm just putting that 9 where that x is. 18 plus 15, and I get 33. So the length of both of these diagonals is going to be equal to 33. Now I'm going to have a question based on this rectangle here. And now we're going to move on to the next section, which is a little bit more conditioned with these rhombuses, rectangles, and squares. Okay, so for this section, I'm going to start off the first 3 theorems. For this part, I'm going to start with the first 2, and then we'll do 3 problems. So theorem 616 says if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. So kind of like the converse of the one before. So ABCD is a parallelogram, and AC and BD are perpendicular, making this beautiful right angle. These opposite sides are parallel. If those criteria fit, then this figure is a rhombus. Next one, theorem 617. If one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. Again, the converse. So ABCD is a parallelogram. All opposite sides are parallel. We have a diagonal bisecting the opposite angles. So that criteria fits. So then this figure would be a rhombus. The next theorem goes into the converse of the diagonals and the rectangle. Alright, so this is the last theorem for this section. This one has to do with diagonals and rectangles. So let's say I'm given a parallelogram, opposite sides are congruent, and also AC and BD are congruent. So opposite sides are parallel. I just said congruent. Opposite sides are parallel, and then the AC, BD are congruent. That means that we have a rectangle here. So all of these three new theorems that we had before are converses of the ones that we had in the first part of this video. Alright, now we're going to go into seeing if we can identify these different types of parallelograms. I forgot the word for a second. Alright, can you conclude that the parallelogram is a rhombus, rectangle, or square? And explain. Okay, so we'll do the one over here first. Can we conclude that this one is a parallelogram, yes or no? Well, yes. Why? Because the diagonals bisect two angles that are opposite of each other. So by the theorem 617, this is a parallelogram. How about this one? We have the diagonals making a perpendicular angle, and then that we also notice that these are also the same length. So could we conclude that this is a parallelogram? Yes. The diagonals are congruent, so by theorem 618 right here, this is a rectangle. But also we have that these are also making perpendicular lines. So this is also a rhombus. Therefore, if it's a rectangle and a rhombus, this parallelogram would be a square. Alright, we're going to go through one more problem, and that'll be it for today. Okay, so we have our last problem here. What value of x is going to make this a rhombus? So we're told that this angle is 6x minus 2, and this angle is 4x plus 8. So we need to make sure that we set these angles equal to each other. ABD is going to have to be the same as CBD. So 6x minus 2 equals 4x plus 8. 2x minus 2 equals 8. 2x equals 10. And then x is equal to 5. We're not going to solve these back into to find the angles. They just want to know what the value of x has to be. For the question, you're going to use this picture here. Okay, that is going to be it for today. I'll leave a question for anything. Make sure you want to say about any of the different theorems we have as well.